Good morning, friends. Today I'm going to deal about variables, which is covered under Research Methodology and Biostatistics course. In my lecture, I'm going to cover the variable in two different angles. First one is I'm going to define about a variable, and then I will be discussing about classification or types of variable. How to define a variable, or what is a variable? So a variable is nothing but an image or perception or a concept which we can measure. That is actually termed as variable. Or otherwise, we can say a variable is the one which will have some characteristic numerical values, and the unique property of a variable is the numerical value is not constant, it will vary from one object to another object in a population. So according to Curlinger, a variable is a property that takes on different values, what I have explained earlier. So classical example for your variable is pH, temperature, agitation rate, pressure, dissolved oxygen, carbon source, percentage of metal ions, etc. etc. These are all classical example for variables which we are using in any biological based experimentation. Now, you can see the definition, a concept which we can measure, an image or perception or concept which we can measure. That is a variable. That means concept cannot be measured. So before understanding variable in a very fantastic way, you should understand the difference between concept and variable. So the basic or fundamental property which demarcates or which discriminate a concept and a variable is concept cannot be measured, whereas variable can be measured. Example for a concept, enzyme inhibition, where you cannot measure enzyme inhibition, whereas you can measure the enzyme inhibition by using different types of variables such as temperature, pH, substrate concentration, enzyme concentration, etc. Similarly, here you can see I have selected a few examples for concept, effectiveness, satisfaction, impact, excellent, etc. Similarly, I have given a few examples for variables, age, income, height, weight. You can see all these sort of variables can be measured. These are all measurable points. These are all measurable factors. Weight 50, 60, 70, you can measure. Height 5 feet, 6 feet, 5.5 feet, 4.5 feet, you can measure. Income 2 lakhs per annum, 3 lakhs per annum, you can measure. But this is dimensionless. Satisfaction, how to measure? There is no unit for satisfaction. There is no unit for effectiveness. So these are all dimensionless where you cannot measure. These are all phenomena, these are all concepts. So the difference between concept and variable is very simple. Concept cannot be measured, variable can be measured. So this you have to keep in mind. How to classify variable? Broadly, you can classify into three types. One is causal model, study design, unit of measurement. Causal model can be subclassified into four types: independent variable, dependent variable, extraneous variable, and intervening variable. Study design can be subclassified into active and attribute variables. Unit of measurement can be subclassified into quantitative, qualitative, continuous, and categorical variables. This categorical variables can be subclassified into constant, dichotomies, and polytomies. Anyway, I'm going to discuss much more about causal model exclusively. Under causal model, you have to focus much more on independent variable and dependent variable. So, as a synopsis or in a nutshell, you should focus much more on dependent variable and independent variable. And something we will link what is actually intervening and extraneous variable. I am not going to discuss much more about the study design and unit of measurement, which is a little bit out of the scope. or out of the scope in the point of a biostatistics. So, what is causal relationship or causal model? To investigate a causal relationship or association, it was governed by four different sets of variable: change or independent variable, outcome or effect or dependent variable, affect or influence or extraneous variable, connecting or linking or intervening variable. So these four different types of variables, namely independent variable, dependent variable, extraneous variable, intervening variable, all these four different types of variables play a major role to explain something about a model termed as a causal model or a causal relationship. So I will be explaining one by one. So you will be observing each and every type. Change or independent variable. So what is change or independent variable? From the word itself you can see change or independent variable means it is this type of variable is responsible to bring some changes in a phenomenon, in a process, in a situation or a circumstance. Responsible for bringing about changes in a phenomenon or situation or circumstance is the role of any independent variable. You see the word independent means they are totally independent. That is the very carefully you have to decide the type of the variable. Very carefully you have to discriminate the levels of each and every variable in order to have a very good response. So they are independent. Very carefully you have to select. Say for example, you want to study the microbial growth kinetics. You want to investigate the optimal growth of a particular microorganism. That is the task. In order to investigate the optimal microbial growth, you can see you have to focus your attention towards pH, temperature, carbon source, nitrogen source, etc. Whatever variable you want to incorporate, you can incorporate. You can see pH. You have to fix the right pH. You have to decide what pH should be fixed over here, 5, 5.5 or 6 or 7. What pH you have to select, what pH you have to select for optimal microbial growth, you have to select. Similarly, temperature. Again, you can see you are measuring the microbial growth using temperature, right? This is dimensionless. Microbial growth is dimensionless, whereas temperature will have some dimension. Say again, what temperature you have to fix: 35 degrees Celsius, 36, 37, 38. You have to decide. Carbon source. What type of carbon source you have to select: glucose or galactose or fructose or maltose or lactose, sucrose. What carbon source appropriately you have to select. You have to decide. And again, for each carbon source, what value you have to fix it. What value you have to fix it. Again, 1 gram or 0.5 gram, you have to decide. Nitrogen source, you have to decide. So very carefully you have to select these type of variables in order to investigate the optimal growth of a microorganism. So pH, temperature, carbon source, nitrogen source were actually termed as independent variables, or these are the variables which are responsible to bring some important changes in the microbial growth. Similarly, you can see you want to investigate the enzyme activity, say alpha amylase, alpha galactosidase, xylanase, arabinase, lactase. You want to study the enzyme activity. So in order to study the enzyme activity, you can make, you can select some changes. You can select some variables like pH, temperature, substrate concentration, enzyme concentration. For each and every variable, what you are going to select will have different unit or different dimension. pH, say 1 to 14, right? Or very clear cutly, if you want to say 0 to 14. Temperature, you decide 30 to 40 degree, 30 to 50 degree. Yes, you select. Substrate concentration, either in micromolar, in microgram, or in millimolar, milligram, you select. So the variables like pH or temperature or substrate concentration or enzyme concentration may be responsible to bring some changes in the enzyme activity. So here substrate concentration is an independent variable, right? So please remember, independent variables are responsible to bring some important changes in a phenomenon or a situation or a process or a circumstances. Now assume that microbial growth is a process, is a phenomenon, right? So this phenomenon can be appropriately investigated with the help of these type of independent variables. Second type of variable is outcome or effect or dependent variable. So in biological sciences or in biotechnology or in broad life sciences, very simple, you can tell this dependent variable as a response. What response you are going to looking, what response you're looking for. So response is nothing but dependent variable, or very simple, it is the outcome what you are going to expect. So outcome or changes which are brought about by an independent variable or a set of independent variables is actually termed as dependent variable. So dependent variable is the output or outcome. Independent variable is the input. In a very simple way, you can explain like this. So microbial growth is an outcome or it is a response what you are looking for. Enzyme inhibition, yield of polyphenol, yield of oligosaccharide from seaweeds, removal of metal, removal of dye. These are all classical examples, biological examples for a dependent variable or examples for responses what you are going to looking for or example for outcome. So please remember, these are all dimensionless. These are all dimensionless. You can quote all these things as an example for a concept. So dependent variable will be a concept, and exactly independent variable is the one which you want to measure, right? So it will be having some numericals. Third point is extraneous variable or influencing variable, or it may affect indirectly in measuring the response. So you will be using a set of variables termed as independent variables to measure the dependent variable or a response. So independent variable will be the input, dependent variable will be the output. So between these two, something will influence, something will affect. So that type of variable is actually termed as extraneous or influence or affect variables. Several factors may be responsible. They can affect the changes in the dependent variable, or they can affect the changes in the response, right? Originally, these type of variables may not be or it would not have been incorporated in the study. You would not have incorporated those variables in the study, but those variables as a hidden factors may be responsible to increase or decrease the response. How to understand? For example, yield of polyphenol is the response, or it is the dependent variable what you have set in an experiment. See, it is affected by the material ratio. So you took material ratio as an independent variable. What is material ratio? Material ratio is nothing but raw material which is dissolved in an extracting solvent. You want to extract polyphenol from a biological source. You are using solvent as an extracting one. So you are using as an extractant any solvent, and from where you are going to extract, it will be the raw material. It could be a plant source or a marine organism or a simple microorganism, whatever it is, a biological source. So the raw material, it could be a gram, or it could be in kilogram. Extracting solvent you can measure in volume. It could be in ml or liter. If you are going to select kilogram raw material, then you have to dissolve in a liter. If you are going to measure the raw material in milligram or gram, and then you can restrict the volume of extracting solvent in ml. Say 1 gram per 100 ml or 0.5 gram per 10 ml. say 20, say 5 kilogram in 2 liter. It all depends upon the type of the experimental condition. So yield of polyphenol is the response or dependent variable, and you have selected material ratio as an independent variable. Now you see, I have focused only the solvent, say acetone, ethanol, methanol, water, hexane, heptane. Just I have focused only the solvent. But now here, what could be the hidden a factor or the influencing variable is, see, I have focused only the solvent, but sometimes the modification of solvent, if I would have modified the solvent, I would have obtained a better yield. What is that modification? Instead of using ethanol as such, 99.5%, that is anhydrous ethanol, sorry, instead of using 99.5% anhydrous ethanol, if I would have modified ethanol with water, what happens? Say 60% ethanol, 60 ml ethanol and 40 ml water, that is 60%. I have modified the ethanol by using water. Now here, I have not incorporated water here. I have incorporated only ethanol, but water is another universal solvent. Adding by addition of water to ethanol, you would have improved the yield. Now here, this modification is can be mentioned as an influencing variable. Similarly, solvent mixture. Instead of selecting hexane, I have focused only on hexane. What happens if I would have mixed hexane with heptane, or hexane with chloroform, or hexane with acetone, right? I have focused my attention towards only a single solvent. What happens if I would have entered into a ratio 1 is to 1, hexane 1 ml, heptane 1 ml, 1 is to 1, or hexane 1 ml, 5 ml of chloroform 1 is to 5, right? That ratio is an influencing or extraneous variable which would have improved my polyphenol yield, right? So since I have selected only hexane, that would have either increased the yield or it would have decreased the yield, that I don't know. So these are all hidden variables which I have not incorporated as an independent variable, right? I have used only ethanol, only hexane, only heptane. I have not modified. I have not used any mixture. So that type of variable is actually termed as an affect or influence or extraneous variable. So again, here you can see another sorry, classical example: smoking and cancer. Always say smoking means smoking is responsible for cancer. We'll say lung cancer or brain tumor or whatever it may be. So I will be assuming smoking, and I will be focusing. I will be setting. Setting up the experiment like this. What type of cigars would have been smoked by an individual? How many? That is what to say. What type of brand of cigars would have been used, filtered brand, non-filtered brand, or other than cigars, what other tobacco usage is there. So I will be focusing my attention. Smoking means I will be putting up all these sort of things as an independent variables. Type of cigars, whether it is filtered cigar, non-filtered cigar. So like this, I will be fixing. But what is the extraneous variable or affecting variable? I would have not considered the age of the person. I would have not considered the extent of smoking. Right, per day, how many times he or she is smoking? Right, 5 cigars or 10 cigars or a packet. I would have not incorporated here. I would have not considered as an independent variable. So age of the person was not considered. The extent of smoking was not considered. Duration of smoking for 5 minutes, 2 minutes, 10 minutes, it was not considered. Whether that particular individual is doing any physical exercise, it would not considered. All these things were hidden factors which may affect in the response, right? So this is another classical example for extraneous variable. These are all extraneous variables for the selected study. Relationship between smoking and cancer. Cancer is a dependent variable, smoking is independent variable, but I have not considered all these things. These are all extraneous variables, examples for extraneous variables. Now the last one is connecting or linking or intervening variable. Very classically, you can say this could be termed as a confounding variable. Again, this is like a hidden variable which links the independent and dependent variable. Classical example here you can see. I want to study again the same example, impact or significance of lung cancer. I thought that lung cancer is mainly because of smoking. I want to study the extent of smoking and lung cancer. I want to relate. Always I will be focusing my attention towards only the smoking angle, right? I will be selecting only the smokers, and as a control, I may be selecting non-smokers. I will be putting many questions based upon only smoking, right? Again, as I said earlier, what type of cigars you are using, whether you are using a filtered cigars or a non-filtered cigars. So the entire study will be focusing on only cigarettes and other type of tobacco usage in the study. So my intention will be is to correlate smoking with lung cancer. Whereas here the confounding variable or the hidden variable is alcohol. See, really speaking, that particular individual may be smoking or seldom. He may be a chronic drinker, not a social drinker. He may be chronic drinker. But in the experimental analysis, in the experimental setup, I would have totally missed this angle. Usage of alcohol, I would not have asked any question related to alcoholism. So I would have focused only on smoking, thinking that smoking is the real and main cause for lung cancer. Yes, it is true, but still, alcohol also play a major role. Since I have formulated my experimental analysis totally related with the smoking and have missed this alcohol, I may get or I may enter into a wrong conclusion, or the study may end up with the wrong conclusion. It should not happen like that. So here we have to confirm that the individual is not consuming any alcohol, or he or she may be a social drinker once in a while, so that very clear cutly I can relate that smoking could be responsible or main factor for causing lung cancer. I have to rule out this, or otherwise, lung cancer for that particular set of individuals, lung cancer would have caused due to alcoholism, but I may end up that smoking could be responsible for causing lung cancer for those individuals also. So here, alcoholism is the confounding variable which we have to rule out. So there is no big difference between intervening variable and extraneous variable with mild difference. Both scope is same, right? We have to very carefully rule out the presence of extraneous variable as well as intervening variable. Thereby, exactly we can link the independent variable with the dependent variable, right? So again, you can see classical example for another example for intervening variable, uh, mortality rate, fertility, that is birth rate and death rate. So I want to investigate the birth rate. So this is the response. For that I have selected the independent variable. But you see here the intervening variable is the extent use of contraceptives, right? Any contraceptives in any form, if it is used, automatically birth rate will be controlled. We have to study this also. Not only that, you can see extraneous variables, socio-economic status, provision and quality of health services, age, religion, provision, so many other extraneous variables should be also taken into account. Very carefully, we have to select the right lot from here, the right lot, this contraceptives, and we have to frame all these things under independent variable. Then only you will get the correct true figure for the birth rate. Number two, study design. As I said earlier, most of the times we may not use these things. Just to understand, I'm going to explain. Study design will be governed by two different sets of variable. One is active variable and attribute variable. The basic difference between active and attribute is active variable is under your control. You can manipulate, you can change whatever you want to do. You can do it. You can decide in your experimental setup. You can decide, you can fix a limit. So those type of variables were actually termed as active variables, whereas the attribute variables where it is out of control or you cannot change it, you cannot manipulate. See, a classical example for active variables, different teaching models. Now here you can divide into many lots, right? Say usage of PowerPoint, usage of overhead projector, usage of slide projector, usage of flipped class, usage of what is a focal group. So you can put so many different teaching models. It is under your control, right? Usage of PowerPoint, how many times it was used by a teacher for 45 hours or 60 hours, how many hours were used by a teacher using PPT. If it is overhead projector, how many hours were used through overhead projector. So it is under your control or it is under the control of a researcher. That is actually termed as active variables. You can change, you can fix, there is a flexibility. Whereas age, you cannot change the age of that particular subject, right? If an object is telling my age is 15 or 20, you cannot change. Similarly, gender, religion, level of motivation, all these things were coming under attribute where you cannot manipulate. Anyway, don't worry, you may get seldom chance to use this type of design in your biostatistical analysis. And last one is unit of measurement again. This is governed by four different set of variables, namely categorical variables, continuous variables, qualitative variables, and quantitative variables. Categorical variables means measured on nominal or ordinal measurement scales. Again, it is subclassified into three types: constant, dichotomous, and polytomous. Dichotomous and polytomous. Say constant means only one value. For example, that is tree or water or taxi or water. Only one category. Ethanol is one category, right? pH one category. Temperature one category. If you are going to use only one lot, one that will be one category. That is actually constant variable, right? You are fixed only one variable. Dichotomous means you will be fixing two categories, right? Say pH and temperature. pH and solvent ratio, male, female, yes, no. So that is dichotomous. Uh, uh, Dichotomous, whereas polytomous means multiple lots will be there. Say three lots: Christian, Muslim, Hindu, Jain, Buddha. Political parties, empty number of political parties you can put. Similarly, solvent ratio, pH, temperature, pressure, you can put multiple lots. So that is polytomous. Anyway, you have to assign some numerical values. So that is the speciality. You can see there should be some measurable scales. Continuous variable means they are made on either an interval or a ratio scale. Anyway, don't worry, we are not going to use such kind of complicated system in our biostatistical analysis. So, friends, hope you understood exactly what is a variable. Anyway, we are going to use only two different types of variables in biostatistical analysis. One is a dependent variable, another one is independent variable. So dependent variable is nothing but the response what we are going to looking for, and independent variable is the one, the factors which are responsible to brought that particular changes. So hope you have understood. Again, if there is any queries, you can mail to me or through live interactions. I will sort out all your doubts. I will clarify all your doubts. So thank you. Thanks a lot for watching.